Hello guys, welcome to my channel. Press the subscribe button like this, and then you have to tap the bell icon adjacent to the subscribe button like this, and then you will get the notifications from my channel.
Hello guys and welcome to my channel. In this video I will be covering the Porter governor. Now this is the lecture 3 of the governor lecture series, and if you have not watched my previous video lecture number 2, you can click on the top right corner I appearing on screen right now. Now let's start with the Porter governor. The Porter governor, it is a modification of the Watt governor, in which in the Porter governor we are considering the sleeve to be having some weight capital M, whereas in Watt governor we were considering the sleeve to be massless. Now here the arms, they are pivoted at a point P. The load, central load, we are considering to be of capital M mass, and the links, they are joined to the sleeve. Now when we draw the free body diagram, so it looks like this, that is the arm considering only, either you can consider right hand side or you can consider left hand side because it is symmetrical. So we are considering here to be left hand side for the derivation purpose. Now the tension T1, it is in the arm BP like this, and we are considering tension T2 in the link BD as shown here, and Fc is the centrifugal force, W is the weight of the ball, that is small m into g, capital W. Now here the sleeve, because the total mass is capital M, so half this portion we are considering, so its value will be m by 2, and when we are writing in term of weight, so m into g, that is W, so we are writing here W by 2, and when we substitute the value of W, it is nothing but m into g by 2. So I hope you are clear why this 2 comes, because the sleeve, it is complete of capital M mass, and when we are considering on either side of the central load axis, then we have to take half of the value, and the radius, it is at distance small r, height of the governor is taken as h, alpha is the angle between this arm and the central axis, whereas beta is the angle between this link and the parallel to the central axis. So this is the free body diagram. Now we would be resolving the forces to calculate. Here I already told m is the small mass of the each ball in kg. This ball mass, W is small m into g, capital M is the weight of the sleeve, central load, and W is capital M into g, R is the radius of rotation of the ball, H is the height in meters of the governor, N is the RPM in revolution per minute, omega is the angular velocity, angular speed, Fc is the centrifugal force, and omega square r, T1, T2 are the tension, or you can say force, alpha, beta I have already explained, angle of inclination with respect to vertical. Now we would be solving for the relation between height and the speed of the governor. Now first is the method of resolution of the forces, in which we are resolving along the x-axis and along the y-axis. Now first we are resolving along the, when we are resolving along the y-axis, then what happens, W by 2, capital W by 2 equal to T2 cos beta, like this. So T2 value comes out to be W by 2 cos beta, and we are substituting the value of W as capital M into G. So finally we get T2 equal to capital Mg by 2 cos beta. This is relation number 1. Now we are considering at this point we have balanced in y direction in this point. Now we are balancing y direction in this point. So at point B, what happens, T1, because this angle is alpha, so this angle will also be alpha, because alternate angles. So this component will be cos, so T1 cos alpha equal to W, and Fc is equal to T1 sin alpha. Alright, whereas this angle is beta, so this angle is also beta, this angle is also beta. So finally we get, at this point when we are balancing the forces, so in x direction it will be Fc is equal to T1 sin alpha plus T2 sin beta, and in y direction it will be T1 cos alpha equal to T2 cos beta. The two relations we are getting. Let me show you. Here you can see T1 cos alpha equal to T2 cos beta plus W, and we are substituting the value of W as small m into g, and value of T2 we have found from here, so mg by 2 cos beta. So T2 cos beta value will be mg by 2. So this is equation number 2, and resolving the forces horizontally we get T1 sin alpha plus T2 sin beta equal to Fc. Again we substitute the value of T2, mg by 2 cos beta, and sin beta by cos beta is tan beta. So finally we get T1 sin alpha equal to Fc minus mg by 2 tan beta. This is equation number 3. Now here you can see we are finding the value of T1 cos alpha, then T1 sin alpha. Then what we do? We divide. So we finally T1 gets cancelled. T1 gets cancelled, and what we are left is only sin alpha by cos alpha. What is sin alpha by cos alpha? It is tan alpha. So tan alpha into this value, this complete value, we are taking this side. So mg by 2 plus small mg into tan alpha equal to Fc minus capital mg by 2 tan beta. Now from here we are getting this relation when we divide this whole by tan alpha. So tan alpha you are taking down, so Fc upon tan alpha minus mg by 2 tan beta upon tan alpha equal to capital mg by 2 plus small mg. Now considering the value of tan beta upon tan alpha equal to some constant q, because this value will be constant for each and every value of beta and alpha. It will be some constant term like 1.2 or 1.4. So we are assuming it to be some value q. So substituting the value of tan beta upon tan alpha equal to q and tan alpha equal to r upon h. Now how we get tan alpha equal to r upon h? Let me show you from the diagram. Tan alpha equal to r upon h, because this is r, this value is r, this value is h. So we are writing tan alpha equal to perpendicular, that is r, upon base, that is h. Alright. So we are substituting these two terms in this equation, that is this equation we are substituting the value of tan alpha equal to r upon h, tan beta upon tan alpha equal to q. So mg by 2 plus mg equal to Fc upon tan alpha, you write r upon h, so it will be Fc into h upon r, and directly we can substitute the value of Fc as m omega square r. So m omega square r into h upon r, this value becomes m omega square r into h upon r minus mg by 2 into tan beta upon tan alpha, we are assuming q, so mg by 2 into q. So up to here we have solved. Now we are taking m omega square h, because r gets cancelled, so m omega square h we remain in this side only, and mg by 2 into q you take this side. So finally we get mg, that is this mg plus mg by 2 gets taken out, and 1 plus q. So finally what we are left is with this equation, m omega square h equal to mg plus capital mg by 2 1 plus q. Now from here we can find the value of h. H is equal to, you divide this term right hand side by m omega square. So when we divide, so what we get, m plus m by 2 1 plus q upon m into g upon omega square. So we have got the relation between height and omega. and we can substitute the value of omega as 2 pi n upon 60. So when we solve for 60 upon 2 pi whole square, then we get 895 value. So finally, when we rearrange the terms, n square becomes m plus m by 2 1 plus q whole upon small m into g by h into this value, and g into 60 upon 2 pi whole square. This value comes out to be 895. You can calculate from the calculator. So this term, that is g 60 upon 2 pi whole square, becomes 895. So what we are left is n square is equal to m plus m by 2 1 plus q upon m into 895 upon h. This is the final derivation, the relation between RPM of the governor and the height of the governor. It's very important, and I hope you have followed up till here. Now this is the relation that we got. Now when tan alpha equal to tan beta and q was tan alpha upon tan beta, so q will become 1. We substitute here 1. So m plus m by 2 into 1 plus 1 equal to 2. So 2 gets cancelled. So finally we get m plus capital M by m into 895 upon h. This relation becomes only when q equal to 1, that is tan alpha equal to tan beta or alpha equal to beta. Also, secondly, what we can derive from this, that if the frictional force is also acting, so we get a term plus minus f within the bracket, and this plus minus sign comes, that is in order to compensate for the frictional losses. So when the sign is positive, it is used when the sleeve moves upwards or the governor speed increases, and the negative sign is used when the sleeve moves downwards or the governor speed decreases. So this relation is also important, that n square is equal to small mg plus capital Mg plus minus f upon mg into 895 upon h, and we have to remember we have to use plus f when the speed of the governor increases. We have to use plus sign. When the speed of the governor decreases, we have to use minus sign. Now the second method for the same derivation, that is the relation between height of the governor and the RPM of the governor, can be derived by using the instantaneous center method. This is the second method in which we are considering the same free body diagram, and we have to produce this DP line forward, and we have to make the perpendicular from the D point, and this is the I center. I. This is the point I, which is the I center for this free body diagram, and now we are calculating the moments about this point I. Now moment about this point I will be Fc into this distance, that is this distance, Fc into bm. We are dropping a perpendicular as well from point B to the ID point, ID line. So this is m. So taking moment about I point, Fc into bm, that is anti-clockwise moment. So we can write minus Fc into bm, and then the second moment can be for this w weight, small w weight, that is w into im, that is clockwise, so it is positive. So minus Fc into bm plus small w into im, and again this capital W, that is the moment can be for this also, capital W by 2 into ID clockwise, this distance, and this is the force W by 2 into ID. So plus capital W by 2 into ID equal to 0. This is the moment about the point I, and when we take this that side, so we will be getting Fc into bm equal to W into im plus W by 2 into ID. We are substituting the value of W and W, so small mg into capital Mg respectively, and then we are dividing throughout by Bm. So Fc is equal to small mg into Im upon Bm plus mg by 2 into Id upon Bm, and Id can be represented by, that is Id can be said to be the sum of Im plus Md. So we are substituting the value of Id as here, and then when we further solve, we can take this separately, Im upon Bm plus Md upon Bm, and now Im upon Bm, you can see from the diagram itself that Im upon Bm, this is tan alpha. Tan alpha is perpendicular, that is Im upon base, that is Bm. So Im upon Bm, you have to substitute value of tan alpha. Similarly, Md upon Bm, so this is value of tan beta, because this angle was alpha, so this angle will be alpha. Corresponding angles, this angle is alpha, this angle is alpha, and this angle is beta. So alternate interior angle, this angle will be beta. So tan beta is equal to Md upon Bm. So Md upon Bm will be equal to tan beta, Im upon Bm will be equal to tan alpha. So finally we get this relation. Now when we solve further, we divide throughout by tan alpha. We are dividing throughout by tan alpha, so Fc upon tan alpha equal to mg plus mg by 2 into 1 plus tan beta upon tan alpha. Again we are taking the value of tan beta upon tan alpha as q. So here it will be Fc upon tan alpha equal to mg plus capital Mg by 2 into 1 plus q. We know that Fc equal to m omega square r and tan alpha equal to r upon h. Tan alpha is equal to perpendicular r upon base h. So we can substitute the values here, and Fc, that is m omega square r, into 1 upon tan alpha, that is h upon r, so r gets cancelled, equal to mg plus capital Mg by 2 1 plus q. So m omega square h equal to mg plus capital Mg by 2 1 plus q. So value of h will be equal to mg plus capital Mg by 2 1 plus q whole upon m omega square. We divide throughout. Again we can take this value common, g value we can take common because it is in both the numerator terms. H will be equal to m plus capital M by 2 into 1 plus q whole upon m into g by omega square. And when tan alpha equal to tan beta, that is alpha equal to beta, then q equal to 1. So 1 plus 1 will be 2, so 2 gets cancelled, m plus capital M by m into g by omega square. So hence the same relation as by the resolution of the forces method we have calculated earlier, we get the same relation. So either you do derivation by this method or the previous method, you should arrive at this point. So in this video I would be stopping here because then the video will be very lengthy. In the next video I will be covering the numericals regarding the Porter governor. That will be video number 4, lecture number 4. So if I found this video helpful, please press the like button, please share my video on social media, and please subscribe if you already not subscribed. And please check the description once for more of my video links and social media links. I will be seeing you in the next video. You can watch other videos appearing on the screen right now also. Till then, take care. Bye bye.